G'day guys, got an algebra question for you today where we've got a function that's given by the formula 8x squared minus 8x plus 1, and we're asked to solve for when this function equals 0, giving our x values as exact values. So basically that's code for we can't use our calculators. So what I'm going to do today, guys, is I'm going to exploit or use the method of completing the square to solve this particular equation. And what I mean by that is we're going to use the perfect square and its properties. And what I mean perfect square, I mean like an x minus a squared. It's a perfect square, which when multiplied out gives us x squared minus 2ax plus a squared. We're going to use this perfect square to sort of factorize the front parts of our equation, and it's going to help us solve it. So what we're going to do first is let's write down what we're asked to solve. So it's 8x squared minus 8x plus 1 equals 0. Now what I like about functions that equal 0 is if we have, say, like this is a non-monic quadratic equation, we can factorize this entire equation by 8. And when I mean that, I'm going to go, well, 8 outside the bracket, x squared minus x plus 1 over 8 equals 0. And what's cool about this is when I divide both sides by 8 to cancel out this value, the right-hand side is still 0. So we're left with x squared minus x plus 1 over 8 equals 0. Now, what this difference of perfect squares sort of method asks us to do is it asks us to basically force the front two terms of our quadratic into a perfect square. Now, you'll notice here that if I have x minus a in brackets, I get x squared minus 2 times ax in like once I've expanded. So what I have to do is if I'm going to go backwards, I have to divide my sort of b term, my second term, by 2. So what I'm going to do is to force this into a perfect square, I'm going to divide that second term by 2, and I'm going to have x minus 1/2, all in brackets, squared. Now what happens is if I have x minus 1/2 in brackets, when I multiply this out, let's just do it over here, x minus 1 over 2, all squared, this is going to equal x squared minus x, which is what we've got, which is what I want, but it's got a final term of plus 1 over 4, which I don't want, because I have 1 over 8. So what I'm going to do is I'm going to get rid of that 1 over 4 term by just taking away 1 over 4. So that negates this 1 over 4 term. And then I'm just going to add back on what I had before, my 1 over 8 equals 0. Now I combine my like terms, 1 over 4, negative 1 over 4 plus 1 over 8 is still negative 1 over 8. So I'm left with x minus 1/2, all squared, minus 1 over 8 equals 0. Now, I've fully factorized my quadratic by completing the square. So now what I can do is I can just solve this like I would normally do, algebraically. So let's just move up here. What I'm going to do is I'm going to move my 1 over 8 to the other side. So I'm left with x minus 1/2 all squared equals positive 1 over 8. I'm going to then take the square root of both sides. So I'm going to have x minus 1/2 is equal to the plus or minus square root of 1 over 8. Now this is going to be equal to, guys, the plus or minus. Now it's very important that you put plus or minus here because when I square this value up here, it doesn't matter if x minus a half is a positive or a negative value. Once I've squared it, it's going to be a positive value. So this here will simplify down to plus or minus 1, because the square root of 1 is just 1, over 2 square root 2. Cool. So what we then do is we take our 1/2 over the other side, and we're left with x equals 1 over 2 plus or minus 1 over 2 square root 2. Now we're going to clean this up a little bit by making the bases the same. So I'm going to times this by root 2 over root 2. And I'm left with x is equal to, so this is going to be square root 2 plus or minus 1 over 2 root 2. And we can't leave our base or our denominator with a third in it, so we have to rationalize it. So I times it both by root 2 on root 2. So in case you guys are wondering how do I rationalize this, I times it by just a fancy version of 1, which is just root 2 over root 2. And I get 2 plus or minus square root 2 on 4. Cool, so I can finish this up with x is equal to 2 plus the square root of 2 divided by 4, or x is equal to 2 minus the square root of 2 divided by 4. And that is all she wrote. So guys, this is a particularly sort of disgusting sort of factorization because of the 1 over 8 term, and we got square roots of 2 and all that kind of stuff. Typically, if you're just new to this kind of method, they won't give you questions that are this sort of algebra intense, but it's it's good to see how it's done with the more complicated ones, so you can see it makes it easier to understand the easier ones. That's very bad English, but oh well. So what we do first is I sort of exploit this fact that I can divide both sides by 8 and still get a 0 term on the right to turn this from a non-monic to a monic quadratic. I then half my second term and put it in a perfect square. I then compensate for the final term that this perfect square will sort of spit out. I then combine my like terms on the back, these two, and then I use algebra to solve it. So guys, it's not a very complicated method. A couple of goes at it and you should be just about fine to do it for life, I guess, like riding a bicycle. You'll never forget how these work. But, just keep practicing, and but most of all, guys, just keep enjoying your maths. I hope to see you back here next time.